Hello students, welcome back to this video. It's me Dipendra and Shrestha. Today I am here with the class 10 science pressure relation. In previous video also we have discussed about the pressure relation. About the Pascal's law we have discussed. When pressure is applied on an enclosed vessel, then increased pressure equally distributed to all sides. About this we have discussed in the previous video. Today we are going to discuss about the density, unit of density, conditions, about the density of liquid and density of object. Similarly, upthrust, unit of upthrust, and some relation of upthrust, some reasonable question related to the upthrust. After that we discuss about the Archimedes principle, and at last we verify the principle of Archimedes in this video. It is very important for exam purpose also. Here we have discussed about three laws about Pascal's law, Archimedes principle, and law of rotation. Out of these three principles or three laws, one law commonly or generally will be asked in your exam. That's why prepare properly. Okay, let's enter into the topics. Density. Density means actually how heavy is the object. How heavy is the object. That is related with the density. We define mass per unit volume. How much mass occupies, how much mass can be kept in unit volume of that object. That is related with the density. Mass per unit volume. Mass per unit volume, that is related with the density. Like if we take cotton in, let's say, 1 meter cube volume, at that time we find the less mass. But if we connect the iron in the same volume, 1 meter cube volume, at that time it will have the more mass, because density D equals to m by v. When there is the less volume, there will be the more density. When there is the more volume, density will be less. Okay. Similarly, density and mass directly proportional. D directly proportional to m. More mass, more density. Less mass, less density. When B is constant. When B is constant, at that time density and mass are directly proportional to each other. So density means the mass per unit volume. Mass per unit volume. D equals to m by v. Unit of mass kg and unit of volume cubic meter or meter cubed. So SI unit of density is kg per meter cube. SI unit of volume is kg per meter cube. Celsius unit is gram per cm cube. Okay, gram per cm cube. Celsius unit. You know density of water. Density of water is considered the standard density, and density of water is 1000 kg per meter cube or 1 gram per cm cube at 4 degrees Celsius. Okay, at 4 degrees Celsius. So density of water is 1000 kg per meter cube. You have to know about this. This density of water is 1000 kg per meter cube. You have to remember, you have to know. In numerical problem, if there is no density of water, then you have to write it yourself. 1000, density of water is 1000, because it is standard, you have to know. Except water, if there is other liquid like mercury, then density will be mentioned in the question. Density of mercury is 13.6 gram per cm cube. We know. So density mass per unit volume. When we keep any object into the water, into the liquid, some object sink, some object float, and some object mix equal to the surface of the water. Upper surface of the object makes equal to the surface of water. It means if we keep some object in water, let's say water, Then some object sinks. Some object float. And some object, upper part of the object makes equal to the surface of water. Three possible conditions we can find. Generally, if density of object is more than density of liquid, if density of object is more than density of liquid, then in such condition object sinks in liquid. If density of object is more than water, then it sinks. Similarly, if the density of object is less than density of liquid, if the density of object is less than density of liquid, in that condition such object floats on water. Okay, floats on water. Less density floats, more density sinks. If the density are equal, density of object and density of liquid are equal, in that condition generally upper face of the object makes equal to the surface of water. Equilibrium position like this. So this is the condition, three conditions of density. Less density floats, more density sinks, equal density makes equal to the surface of liquid or water. We can do experiment. Let's say here is a beaker with water. Yeah, here is beaker with water. This is plastic cap. Put here. Now it floats. We can see floating this lid because density of plastic is less than water. That's why it floats. But in the same case, if we put this object here, look, it sinks. Density of that object is more than water, so sinks. But if the density of object and this density of water is equal, then it makes upper surface of water and upper part of the object makes equal surface or equal position we can find. So this is a density case. You know, wood floats on water. Piece of wood floats on water. Why? Density of wood is less than water, so it floats. Stone, iron sinks in water. Why? Density of iron, density of stone is more than water. So more density sinks, less density float. Let's say an iron ball sinks in water but floats on mercury. Why? An iron ball, piece of iron, let's say, piece of iron sinks in water but floats on mercury. Why? Because density of iron is more than water. That's why it sinks. And floats on mercury. Why? Because density of iron is less than mercury, so it floats. Yeah, less density floats, more density sinks. That is the condition. Okay. After this, we are going to discuss about the upthrust. Before upthrust, we have to know about the thrust. Yeah, thrust. Thrust means actually force. So, thrust means force. Perpendicular force in any direction. Yeah, in any direction, perpendicular force. That is the thrust. Upthrust. Up means upward direction. So now upthrust means upward force. Okay, upward force. Okay, so let's say take one umbrella, an umbrella. Okay, take an umbrella, open it and pull up and down like this way, up and down. While pulling down the umbrella, what do you feel? How do you feel? I think you feel little bit difficult while pulling down because here push the umbrella upward direction. This upward force is upthrust. Yeah, upward force is upthrust. We pull downward, but here push upward. That is the upthrust. Here we are going to discuss about the upthrust of liquid generally. Okay, here is upthrust of liquid. So upthrust means actually upward force. While keeping any object in water, any object in water, two types of force X on it. Can you guess what are they? When any object is put or is kept in water, two types of force comes in action. What are they? Do you know? Yes. One downward force. Downward force, that is the gravity. Downward force is gravity. And another upward force, that is the upthrust. Okay? Downward force, gravity. Our earth pulls every object towards its center. That is downward force. That is gravity, you see. And at the same time, liquid or water exerts upward force. That is called upthrust. Okay? Upthrust. Two forces are coming action. So, resultant or net upward force. Resultant or net upward force given by the liquid on the surface of object kept in it. That is called upthrust. Upthrust means net upward force. Okay? Net upward force. Net upward force given by the liquid on the surface of object kept on it, in it, is called upthrust. Net upward force. So when we keep any object in liquid, it pulls downward and water pushes upward. So how much force exerted by the upward? Net upward force given by the liquid on the surface of object. That is called upthrust. Upthrust is force. Yeah, net upward force. And unit of force, you know, Newton. That's why unit of upthrust is also Newton. Okay, unit of upthrust is also Newton. So, due to the upthrust, resultant force of gravity decreases. Due to upthrust, resultant force of gravity decreases because this liquid exerts the upward force and gravity pulls downward force. Yeah, downward force. We say gravity means weight of object. Gravity means weight of object. So, weight of a body decreases due to upthrust. Weight of a body decreases due to upthrust because this resultant force of gravity decreases by the upthrust. Let's say here, in this condition, let's say upthrust is 2 Newton, let's say. Gravity is acting 10 Newton, let's say. Then resultant weight of this object will be 10 minus 2 equals to 8 Newton only we find. 8 Newton. So weight of the object in liquid, weight of object in water decreases because of the upthrust. Yeah, because of upthrust. This liquid exerts upward force because of which the resultant force of gravity decreases due to which weight of object decreases in water. So, you know, an egg sinks in pure water but floats on salt solution. Do you know? Let's see here. This is clean water. Here is an egg. Let's put in water. You can see egg is at the bottom. That means egg sinks in water, pure water. Why? Density of egg is more than water. Density of egg is more than water. That's why we can see egg is at the bottom of beaker. Now let's put some salt in water. Okay? Salt in water. Here is salt. Okay? So I have kept some salt here. Stir it. It is salt solution. When we dissolve some salt in water, its density increases. Its density increases. Now, keep the same egg in water. You can see, egg is floating. Yeah, egg is floating. So, egg floats on salt solution. Why? Why? An egg sinks in pure water but floats on salt solution. Why? Because density of egg is more than pure water. That's why it sinks. But density of salt solution is more than pure water. Density of salt solution is more than pure water, and it can give some more upthrust to the egg. It can give more upward force to the egg, because of which egg floats on water, salt solution. Floats on salt solution, okay? Due to the more upthrust. When we dissolve the salt, its density increases. More density, more upthrust will be. Density and upthrust are directly proportional to each other. That's why when we keep the egg on water, it floats because of more upthrust, because of more density of salt solution, okay? So don't forget, here is one relation. Actually, upthrust of object depends on three factors. We say V rho Z, okay? V rho Z. This is called rho. Yeah, seems like Nepali 9 number. No, yeah, this is called rho. Rho means density, okay? B means volume of object. Volume of object. Rho means density. Rho means density of liquid. And Z means acceleration due to gravity. And all are directly proportional to each other. Don't forget this lesson also. So actually upthrust does not depend on mass. It depends on volume of object. Volume of object. How much part is inside the water? How much part is inside the liquid? Related with this. So volume of object. Similarly, density of liquid. Density of liquid. You know density of water 1000, of mercury 13,600. And acceleration due to gravity. Acceleration due to gravity is differ with place. So all these three terms are directly proportional to the upthrust. When the more volume of object is inside the liquid, then it gets more upthrust. One. Less volume is inside the liquid, less upthrust. Similarly, density. If the density of liquid is more, then upthrust also it exerts more. Less density of liquid exerts less upthrust. Similarly, acceleration due to gravity. If the acceleration due to gravity is more, like at the pole, then upthrust also will be more. And less acceleration due to gravity, like the equator, then upthrust also less. So remember, in exam sometime may ask, what is the relation between upthrust and density of liquid? Don't forget, all three terms are directly proportional. So upthrust and density of liquid directly proportional to each other. Volume directly proportional to each other. Acceleration due to gravity directly proportional to each other. That's all. And egg floats on salt solution. Why? Because density of salt solution is more than pure water. When the density is more, upthrust is more. More upthrust gives more force, more upward force, because of which it floats. Yeah, I think you know, you have such experience. During the flood, we can pull very big log also on water. But on the ground, we cannot even move it. Why? How it is possible? During the flood, we can pull the very big log also, we can pull easily. But on the ground, even we cannot move it. Why? Now it is possible. During the flood, there is water. Water gives upward force, upthrust, and upthrust decreases the weight of object, and we feel easy to pull. But on the ground, only air gives negligible upthrust, and we have to use more force to move it, which may not be sufficient. That's why we cannot move that object. Do you have such experience pulling water from the well, drawing water from the well? While drawing the water from the well, we feel easy until the bucket is inside the water of well. But when the bucket leaves the surface of water, then we feel it will be difficult to pull. Why? Until the bucket is inside the water of well, we feel easy to pull. But when the bucket leaves the surface of water, we feel difficult. Why? Very important, reasonable question for your exam purpose. Until the bucket is inside the water, bucket gets upthrust of water. Water gives upthrust. Yeah, water gives upthrust to the bucket, because of which weight of bucket decreases here, and less effort is sufficient to pull. But when the bucket leaves the surface of water, there is negligible upthrust of air, and we have to use more effort to pull out. That's why we feel difficult. Until the bucket is inside the water, water exerts the upward force, upthrust, and we have to use less effort to pull it, because weight decreases here. There is less weight. But when it leaves the surface of water, yeah, when the bucket leaves the surface of water, then there is a negligible upthrust of air, and we have to use more effort to pull it. That's why it is difficult outside of the water level and easy inside the water level. That is also related with the upthrust. After this, you know, it is easy to swim in sea than that of the river. Density of sea water, that is the salty water, is more, exerts more upthrust. Yeah, that means this sea water pushes our body upward, and we feel easy to float. Yeah, so that is also related with the upthrust. Okay, so upthrust means net upward force given by the liquid on the surface of object kept in it. Yeah, and upthrust decreases the weight of object in liquid. Yeah, upthrust decreases the weight of object in liquid. Why? Because upthrust exerts the upward force, gravity exerts downward force, because of which resultant force will be less than that of the actual gravity, because of which weight of a body will be less in liquid. And don't forget, upthrust is directly proportional to the density of liquid. Okay. After this, we are going to discuss about the Archimedes principle. Archimedes principle. Archimedes principle. Archimedes established one principle related with the upthrust and displaced liquid. You know, when we keep any object into the liquid, it displaces the liquid equal to its volume, own volume. Yeah, when we keep any object inside the liquid, then the object displaces the liquid equal to its volume. But Archimedes established another fact here. He said that whether the object is completely or partially immersed in water, Archimedes said that whether the object is partially or completely immersed in water or immersed in liquid, it gives upthrust. And he said that this upthrust is equals to weight of displaced liquid. After keeping the object in water, it displaces some water. And this weight of displaced water and this upthrust given by the liquid on that object are equal. He said that. So, upthrust, Archimedes principle, to remember, okay, upthrust equals to weight of displaced liquid. You have to remember this. Upthrust equals to weight of displaced liquid, whether the object is completely or partially immersed. So, whether the object is partially or completely immersed, then the upthrust gained by the object is equals to the weight of displaced liquid by it. After keeping the object in liquid, it displaces some liquid. and at that time object get upthrust also. This upthrust and displaced liquid weight will be equal. It is given by the Archimedes. This is called Archimedes principle and frequently asked in your exam also. Don't forget. So Archimedes principle states that upthrust gained by the object is equals to weight of displaced liquid when the object is partially or completely immersed. That is called Archimedes principle. It is applicable for both floating and sinking object. It is applicable for both floating and sinking object. It is valid for both liquid and gas medium. Okay, it is valid for both liquid and gas medium. Archimedes principle. So Archimedes principle is used to prepare the hydrometer, lactometer, ship, submarine, etc. Now we are going to verify the Archimedes principle. Okay, we are going to verify the Archimedes principle experimentally. Experimentally, we are going to verify the Archimedes principle. So, Archimedes principle verification. Verification of Archimedes principle. Verification of Archimedes principle. For this purpose, we use these terms, okay? Weight of object in air, W1. Weight of object on water, W2. Weight of empty beaker, W3. Weight of beaker plus displaced water, W4. Let's do experiment here. For this purpose, we have to use a spring balance. Let's say this is a spring balance. And we are going to use another solid object. This is solid object. Okay. Next one, we are going to use this vessel. This is called Eureka can. Okay. Eureka can. And this, this is salt. Oh, this is a beaker. Beaker, we are going to use empty beaker here. So here we have to use Eureka can, spring balance, beaker, and top and balance also. Top and balance are weight measuring instrument. Top and balance. This is also we have to use. Okay, so at first we have to check weight of object in air by using the spring balance. By using spring balance, we are going to record the weight of object in air. So it is 200 gram, means 2 Newton. 200 gram. Or 2 Newton here. So it is 200 gram, that means 2 Newton. 2 Newton. Now we have to measure the weight of same object in Eureka can. Before that, we want to take weight of empty beaker. Weight of empty beaker, it is 160 gram. 160 gram means 1.6 Newton. Okay, you can see here 160 gram or 1.6 Newton. Empty beaker. Empty beaker weight is empty beaker weight is 160 gram equals to 1.6 Newton. Now let's measure the weight of air. We have before that we have to pour the water on this Eureka can until it's so. Now I'm going to put this solid object into the Eureka can. When I immerse this solid object into this water, then some water will be displaced, and this displaced water we have to collect in the beaker, and we have to calculate the weight of this displaced water also. That's why in top and balance I am going to collect the water. Okay, wait for some time. So here, after immersing this object into the Eureka can, it displaces the water. Yeah, it displaces the water, and at the same time we have to record the weight of that object in water. You know, water gives upthrust and its weight decreases. So here I can see weight of this object in water is about 120, 40, 60, 160 gram. Weight of object in water is 160 gram. Here is you can see here 160 gram. Okay, weight of object in water 160 gram. I have found this weight of object in water is 160 gram. It means again 1.6 Newton. Now I have collected the water. I have collected the displaced water here. We have already recorded this empty beaker weight is 1.6 gram. Now let's measure the weight of beaker and water. Weight of beaker and water. Here you can see it is 200 gram. 200 gram. You can see this weight of beaker and water. This displaced water and beaker weight. Yeah, you can see here 200 gram. Okay, 200 gram. So let's calculate. There is 200 gram. 200 gram means again 2 Newton. 2 Newton. Then how much weight is reduced in water? How much weight of that solid object is reduced in water? Loss of weight. Loss of weight of object in water. In water equals to, that is, how can you calculate loss of weight? W1 minus W2. Weight of object in air minus weight of object in water. W1 minus W2. W1 minus W2. It will be how much? W1 means 200 or 2 Newton. 2 Newton. Okay. Minus W2 means 1.6 Newton. 1.6 Newton. So result will be 0.4 Newton. 0.4 Newton. Similarly, only displaced water. This is the weight of empty beaker. This is the weight of beaker and water. Displaced water. So only displaced water. How much water is displaced by that object? So weight of displaced water. That is, you can calculate W4 minus W3. This is water plus beaker. This is only beaker. So if we subtract beaker, then only remains water weight. So here W4 minus W3. Its weight will be how much? 200 and 1.6. Here also 2 Newton minus 1.6 Newton. It means also 0.4 Newton. So by the experiment, what you find? W1 minus W2 equals to W4 minus W3 we got. Here also 0.4 Newton, here also 0.4 Newton. W1 minus W2 also 0.4 Newton, and W4 minus W3 also 0.4 Newton. Experiment we have found that W1 minus W2 equals to W4 minus W3 we can write. And W1 minus W2 means what? Loss of weight of object. Loss of weight of object because of upthrust. Because of upthrust. Weight of object reduce, weight of object loss because of upthrust. That's why we can write here upthrust. Upthrust. Okay, this is the upthrust. And W4 minus W3. W4 minus W3 means weight of displaced liquid. Weight of displaced water. Okay. Water. Which is Archimedes principle. Yeah, which is Archimedes principle. Already we have discussed Archimedes principle. Upthrust is equals to weight of displaced liquid when the object is partially or completely immersed. We have this already. So experiment also we have found that. That's why it is verified. Archimedes principle verified. Upthrust and weight of displaced liquid will be equal. Okay, how do you feel? What do you find here? If you have any question, then you can comment in it. You can comment in Facebook also. So today, like it, subscribe it, comment it,